Diagram shows a curve with equation y equals 3x plus 2 over ln x. M is a minimum point. We need to find an expression for dy dx and show that the x coordinates of M satisfy the equation given. To find an expression for dy dx, since y is in the form of u over v, so we need to apply the quotient rule. Applying the quotient rule, we have ln x, and we multiply this by the derivative of the numerator, which is a 3, minus, we hold the numerator 3x plus 2, and differentiate ln x with respect to x. That gives us 1 over x. All this is over the square of the denominator, so you have the square of ln x. And we can write this as 3 ln x minus 3x plus 2 times 1 over x, all over the square of ln x. That will give us dy dx. We now need to show that the x coordinate of M satisfy this equation. At point M, since it is a minimum, dy dx is 0. So we set dy dx to 0, then we have 3 ln x minus 3x plus 2 times 1 over x, all over the square of ln x equals 0. So if this part here is 0, when we cross multiply the denominator over, then we have 3 ln x minus 3x plus 2 times 1 over x. This is 0. And we can rearrange this equation so that 3x plus 2 times 1 over x. We can write this as 3x plus 2 over x. You can just move this over and then flip again. This is 3 ln x. Now flipping both sides for this case, so that x over 3x plus 2, this is 1 over 3 ln x. Multiplying that right across, we have x equals 3x plus 2 over 3 ln x. And that is what we are asked to show for part A. For part B, use the equation in part A, meaning that this equation, to show by calculation that the x coordinate of M lies between 3 and 4. So we can convert this into a function, move the right side over to the left side, and we can let fx to be x minus 3x plus 2 over 3 ln x. What we just need to show is that fx has a 0 in between 3 and 4. So we find f of 3, and that is 3 minus, we replace x with 3, that would be 9 plus 2, which is 11, over 3 ln 3. That is negative 0.3375. And f at 4, we replace x with 4. So we have 4 minus, that is 12 plus 2, that would be 14 over 3 ln 4, which is 0.6337. Now we see that f of 3 is less than 0 and f of 4 is greater than 0. That means fx must be 0 for a value of x in between 3 and 4. So from here we say that the x coordinate of M is in between 3 and 4. Part C, use an iterative formula based on the equation in part A. So we are looking at this equation to find the x coordinate of M correct to 5 significant figures. The result of each iteration must be to 7 significant figures. So from this equation, we set x of x sub n plus 1. This is 3x sub n plus 2 over 3 ln x sub n. The starting value, we could either use a 3 or a 4, but 3 is closer to 0 than 4, so we could let x naught to be 3. Then x1 here is 3x naught plus 2 over 3 ln x naught. So that is 3 times 3 plus 2 over 3 ln 3. And that has a value of 3.337544 to 7 significant figures. Then x sub 2 here is 3x sub 1 plus 2 over 3 ln x sub 1. We use this value to compute x sub 2 now. We just dump all these values in and use a calculator. That gives us 3.322348. Well, to 5 significant figures, they do not converge. Let's try x sub 3. This is 3x sub 2 plus 2 over 3 ln x sub 2. So we use this value to compute x sub 3, and we get 3.322319. So to 5 significant figures, that is 3.3223. That is 3.3223. These two converges to 5 significant figures. We only need to compute the next one. So you need 3 of them to converge to 5, to be the same to 5 significant figures. Then that is 3x sub 3 plus 2 over 3 ln x sub 3. We use this x sub 3 value and we compute x sub 4 to obtain 3.322319. To 5 significant figures, we have 3.3223. And in that case, the x coordinates of M has a value of 3.3223 to 5 significant figures.